Hi, this question is from semester 7, question 6 on the exam paper. And this is a system of 3 linear equations, and you have to find the solutions for x1, x2, and x3. It can be done using simultaneous equations, which isn't part of this course, or Gaussian elimination, which is what we will do now, or LU decomposition, which I will do in the next video. So what we have is the first thing to do is see where this mouse is, right? Okay, I'll have to change the color of this mouse, whatever it's called. Right, so I can see it. We'll convert this here system of linear equations into matrix format. So we take the coefficients of the x's, and that's going to be 1, 2, minus 3 on the top row, 2, 5, and minus 1 on the second row. And the third row we have 3, minus 1, minus 1. Now what we do is we create the augmented matrix because we're going to use Gaussian elimination, and we'll put the solutions to the equations 2, 10, and 7. 2, 10, and 7. And this is our augmented matrix. Now, the x1, x2, and x3 are really here. This first column is the x1 column. The second column is the x2 column. And the third column is the x3 column. To do Gaussian elimination, we want to get this lower triangle here of 3 numbers made into 0. And we have a sequence to do this. So the first one to become 0 is the 2, which means we're going to have to add, subtract, or multiply out the rows to try to get rid of this 2 and make it into a 1. So that means what we're going to do is we're going to change row 2, and row 2 will become, so if we say row 2, which is 2, and we take away 2 of row 1, that means 2 ones, that will become 0. So the row 2 becomes a new row 2, which is going to be row 2 minus 2 row 1. Now that means that row 1 and row 3 aren't going to change. So I can rewrite row 1 and row 3 now. 1, 2 minus 3, and 2. And row 3, which is 3 minus 1, minus 1, and 7. And I have to fill in the new row 2. So the mathematics for that are going to be, just scroll up a bit. So the new row 2 is going to be 2. So it's row 2 minus 2 row 1. So it's going to be 2 minus 2 times, so this 2 here, minus 2 times this 1, minus 2 ones, which is 0, which is what we want. So that's there. The next value is 5 minus 2. So it's 5 minus 2 twos. That's the x2. So it's 5 minus 4, which is 1. Put that up in there. And the next one is minus 1, minus 2. And above the minus 1 is minus 3. Minus 2 times minus 3. And that will be 2 3s are 6. That becomes a plus 6. Minus 1 is 5. So this value in here is 5. And also we have to do the augmented part of the matrix, which is going to be 10 minus 2 times, so 10 minus 2 twos, that's a 2 there. 10 minus 2 twos, which is 10 minus 4, which is 6. 6. So this is our new matrix right now. 1, 2 minus 3, 2, 0, 1, 5, 6, and 3 minus 1, minus 1, 7. Right. So we have made this position 0 first. Now we're going to make this position 0. So this is the matrix we're working on. And this one here is going to have to become 0 now, this 3. So that means we're now going to be working in row 3. So row 1 and row 2 are going to stay the same. But to get rid of the 3 here, we're going to have to say 3, or one of these one of these rows, row 3, minus 3 row 1s. So we'll be taking 3 1s away from it, and that will become 0. So I'll do that over here. So we have the next stage is going to be row 3 minus 3 row 1. And that's what row 3 is going to become. So we can write row 1 and row 2 together. That's okay. 1, 2 minus 3 and 2 and 0, 1, 5 and 6. And it's the third row now that has to be sorted out. So it's going to be row 3 minus 3 row 2. Or sorry, row 3 minus 3 row 1. I have to pan up a little bit. So row 3 is 3 minus 3 times 1. So we're working here 3 minus 3 1s, which is 3 minus 3, which is 0. That's the way we've designed it, so that becomes 0. And then the next one is minus 1 minus 3 2s. Which is minus 1 minus 6, that's a 2, minus 1 minus 6, which is minus 7. So we have a minus 7 here. Okay, and then the next one is going to be minus 1 minus 3 minus 3. Oh, sorry. Minus 1 minus 3 times minus 3. And that equals 3 3s are 9. Minus by minus is plus 9 minus 1. 9 minus 1 is 8. So that's 8 goes in there. And then the last one here is 7 minus 3 2s. Which is 7 minus 6, which leaves me with 1. Goes in here. Now you can check, like these here, 1, 3 minus 1 minus 1, 7. They are 3 minus 1 minus 1, 7. 3 here, down here, is part of the formula, the minus 3. And then the values from row 1 were 1, 2, minus 3, 2. 1, 2, minus 3, 2. Okay, so now we have got these two 0. And then the next thing we have to do is we have to make this here 7. This here position now has to become 0. So we're going to use this matrix now for the third stage. So I'll have to do here. This is step 2 then if you want to say step 2. And now the next one is step 3. I'll pan down a little bit. And we're going to use this matrix here. I'll write step 3 over here. Yeah, so step 3. We want to change this 7 to make it 0, this minus 7. And we can only use, at this stage, we can only use row 2 and row 3. Because if we try to use row 1 again, we will lose this 0. Because if we subtract something that's non-zero, we'll lose a 0. So we can only use a combination of row 2 and row 3. That's not too bad though. If we say minus 7 plus 7, it would be 0. So if we say minus 7 plus 7 row 2. So if row 3 will now become row 3 now becomes row 3, which is minus 7, plus 7, row 2. So that means row 1 and row 2 don't change. We can write them down now. 1, 2, minus 3, and 2, 0, 1, 5, and 6. And row 3 is going to change. So row 3 becomes row 3, which is, for the first one, it's 0 minus 7 zeros, which is 0. So the first one stays the same. Then we have minus 7. Oh, sorry, plus. Should be a plus in there. So that makes no difference there. But plus 7 ones. So it's this minus 7 plus 7 of these ones, which is minus 7 plus 7, which is 0. That's great. That will go there, 0. And then the next one is 8 here, plus 5, plus 7 fives. Okay, so 8 plus 7 times 5, which is 35 and 8, 43. And then the last one is, so I'll put 43 in here now. And the last one is 1 plus 7 times 6. That's there. 1 plus 7 sixes. So 7 sixes are 42 plus 1 is 43. 43, I put 43 in here. Now, we're at the stage now where we do what you call back substitution. Because we now have these 3 zeros as required, we've got just one element here in this part of the matrix on the x3s. We have here in this row we have 2 elements, and in this row we have 3 elements. So 3x elements. Let's just pan down a little bit. And now we're working with this matrix here. So we're doing back substitution. I just call it back sub for convenience, right? So remember I said at the start, this column is the x1s, this is the x2s, and the third column is the x3s. So we can say 43 x3, that's this one here, is equal to 43. And that's this 43 here. So that means x3 must be 1. That's our first value. Then we look at the next row, and we have, this is the x2 column and the x3 column. We have 1x2, which you can write as x2, plus 5x3 equals 6. But we know x3 equals 1, so we can say x2 plus 5 ones, which are 5, equals 6. So that means x2 must equal 6 minus 5, which is 1. So we have x2 equals 1. We have x3 equals 1 and x2 equals 1. And the last stage, we use the top equation, 1x1 plus 2x2 minus 3x3 equals 2. And we will find x3 or x2 or x1, right? So 1x1 plus 2x2 minus 3x3 equals 2. But we've got a value for x2 of 1, and we have a value of x3 of 1. So now we can say x1 plus 2 ones minus 3 ones equals 2. So that's x2, or x1 plus, no, it's, yeah, well, plus 2 minus 3 plus 2 minus 3 equals 2. And when we sort that out, we'll have x1 equals 3. The 2's will cancel, the 3 goes the other side. x1 equals 3. We sort that out. So the solution is x1 equals 3, x2 equals 1, and x3 equals 1. And it can be written as 3, 1, 1 if you want, like as a vector. Okay, that's the solution. Thank you.